Yeah, now it started. Great, awesome, good. Well, welcome everyone to this special edition of the MonteVIDEO Tech Meetup, where we're going to do the kickoff of the summer projects for this year. Woohoo! And that's awesome. So just recap, if it's your first time here or something, what is the summer camp and summer projects about? First, let's talk about the summer projects. So the idea behind the summer projects is to give back to the video community and to promote the collaborative culture. And the idea is to do some open source projects together with the idea to create value while we learn and share knowledge together. So that's the main idea. The real focus of the summer projects is to be together, do some cool stuff and learn. That's the main reason because why we are doing this. And of course, if we do something that is valuable, ooh, awesome. So with that, our technical sponsors for this years are going to be David, Hasoon, and Mike English. And that's great. I think you already know because we put a lot of stuff over there, over the networks, LinkedIn and Video Dev and all that. So yay, claps. And let's do a brief overview of the summer camp. So the summer camp, let's say that it starts today. Is your winter? I know, David, it's snowing, but here it's summer, so great. That's why you have to come here. So we are starting today with the summer projects. We're doing the kickoff of that. And then we are going to have a summer week that it's going to be on January 26th to the 1st of February of next year. So that's the real summer week and the real experience for the be together and do some fun stuff. And also today we are starting the definition and development of two of the two summer projects that are the VAST to server guided ad insertion and the MediaWare Quick Player. The idea is that we are going to be together uh, defining and learning about these technologies, and then we're going to do a demo of what we achieve. It will be a hybrid demo on the same week as we have the summer week. And the main question we have to solve here is how to get involved. Three things. First, follow the repositories of the projects. I'm going to share the links after this. The second thing you have to do is join the weekly calls. In that weekly calls, we are going to talk about the projects and what we need to know. We are going to learn together, and we are going to develop some of the stuff we decided we have to do. And the last thing is keep in touch, keep involved, mainly in videodev.org Slack. We created a channel for that, just going to share with you. And also for the MediaWare Quick project, we're going to be at Discord joining the quick.video community because there are people who understand MediaWare Quick is over there. So let's go where the people who knows MediaWare Quick is. And this is the part where you should take the screenshot. Yay! So these are the information for the projects. If you want to follow the VAST to server guided insertion, that's the repository. Is on the MonteVIDEO Tech repo. We are going to meet every Thursday, 9 a.m. There's the link. The link is not going to change. And the channel in Slack is MonteVIDEO Summer Projects. For MediaWare Quick Player, the same is MonteVIDEO Tech / MediaWare Quick Player. We are going also to meet every Tuesday, 10 a.m. The link is over there, and also check out the same channels for communication. This is very important. I just take a screenshot. We're going to share this also on Slack, so you don't lose any of the links here. Also, remember this. I saw this some weeks ago, Mike, that there is going to be a MediaWare Quick workshop next Thursday, right? So
It's Wednesday.
Wednesday. Okay. So yeah, you can subscribe and go there, and I think it's a great opportunity to do like the kickoff and start doing something with MonteVIDEO Week, and then we continue in the summer projects. So this is great. At last, about the summer week agenda, if you're thinking about coming to MonteVIDEO, we already have the agenda. So this is great. You should take also a picture of this, because we are going to start on Sunday up to Saturday. And it is that we are going to have, yay, thank you, Mike. We are going to start with a dinner at JP's home. Then we are going to have a campfire opening on Monday. And Tuesday, we're going to have a roundtable and discussions and some online events also. Then tech talks, the demos, and at last, we are going to go to the beach and do some to the countryside and do some good stuff like eating and go to wineries and all that kind of stuff. So perfect for summer. And and that's it. Thank you. I'm going to share with you all the links on video dev, so you're not going to lose any of that information. And with this, let's go with David's talk to get started and understanding a little more about what is server-guided ad insertion. Thank you, everyone.
You guys see it all right?
Yep, looks good.
All right, so I'm gonna kind of run you guys through this. It's gonna go a little fast. I get all excited and then I just don't stop. But it's gonna kind of go through some of the basics, advertising and then how SGAI fits into it and kind of what it is a little bit. And then we'll kind of end on, well, and this is what we're gonna be focusing to help enable more people to easily adopt SGAI, whether it's in just kind of trying it out or hopefully, towards larger scale production as well. So let's start at the beginning and see how this all goes. And all right, so first, a couple thanks. I've pretty much borrowed and stole some slides from wonderful people and groups out there, as well as creating some of them. So one of the thanks to the SGAI advertising group. They have some awesome resources, Zach Kava, and also Ben Rowland at Dolby. First off, let's start at the top of this. What are the different type of ads, right? So you have a placement. Here's your content. You might have a pre-roll ad, right? Goes in the beginning. Mid-roll ad going to be somewhere in between, and then you can have post-roll at the end. There are interactive ads, things like Choose Your Destiny, full interactive non-video ads, click to go to, time-gated ads, all sorts of other goodies that you can do around that. And now you get to also where something that's actually becoming a lot more prevalent and something that actually SGAI is really kind of powerful on taking a step further as well is multiple view experiences. Instead of just having a linear experience of ad, content, in just a square box, you can do things like a pullback ad, you can do picture-in-picture, side-by-side, L layouts, all sorts of other good stuff on how you can actually render and create a hopefully more engaging, or let's just say less obtrusive or intrusive experience for users. So when we look at the types of ad insertion, right, there's ad content insertion, which means that, hey, the total playout duration, if it's an hour video and you're adding in 10 minutes in ads, the total experience is going to be an hour and 10 minutes for the whole thing once it's done. So you're actually splicing in ads and extending the content between there. Real common for VOD, right? You don't want to miss anything in VOD, but you might want to inject that ad at a certain time. There's also ad content replacement, and that's when the total duration doesn't change and it's still the same, but what you're going to do is you're going to take your content and you're actually going to replace it instead of inject your ad into that. Real common case there is live. Well, you might still have your main content feed that's just showing people standing around on the sidelines while you're running your ads that are really what the users are going to see, or it's going to be slated out, which is more common. So that the main content feed just has slate while you run your ads that are dynamic and inputted on top of that time period. Third, but not really what we're focusing on, is things like pass through or burnt in ads, right? This is when it's actually part of the content feed. They're technically ads that are there, and they've been burnt in. A lot of times the Super Bowl, this is actually what they do. One, because they get the best, coolest ads. They're more fun. But you don't lose out on the personalization, one of the power of streaming video. However, even though it might be burnt in, you'll still be doing things like data tracking, so you can get your money for all the eyeballs they got to see there. So they'll do impression tracking during those ads, even when it's burnt into the main content feed. So within the manifest, you'll still have markers indicating, hey, there's an ad here, but ultimately it just looks like the next segment and nothing special. So let's also line up on some terminology, right? There's the player. A player is a software component, an application provided a streaming URL to, right? A good way to think about this in more concrete terms is, things like HLS.js, AV Foundation, ExoPlayer, right? And then you have the application. That's going to be the software stack that utilizes that player component to create the whole experience, right? So now that we've established that, let's look at what these different types of ad solutions really are. So where things kind of started originally was in client-side ad insertion. Client-side ad insertion has the media presentation between your ad and content can be separate streams. The actual coordinator that controls that experience to show content ad is going to be the application, right? And it started off a lot of times in dual players, right? There were ways to do some more advanced stuff and so forth, but that was what the initial kind of client-side ad insertion meant. And the benefit, of course, is also distributed scale. Like, there's not a centralized point that was a bottleneck for this, because every client had to create their own experience and deal with the two players and so forth. Then came server-side ad insertion, which is still the king right now, but it's getting challenged. The media presentation was a stitch stream, meaning that the server actually combined the ad and the content into a single stream and passed that down to the individual users. The coordinators done at the service, the server side. Seamless requirements were done with just a single player, right? It just came in as a single manifest, and it created a good experience. It also helped with avoiding things like ad blockers. Scale type, though, is centralized. This was a big problem when that server side first came out, especially because it couldn't always handle a very high bursting load if you're doing and maintaining an individual session for each individual user that's going on there, let alone the time it takes and VOD and other aspects that come into a challenging list of issues when you have a centralized system for all your ads. So what server-guided ad insertion SGAI, see, there's a reason we're going through all this. We had to add up to it. Is so powerful is it kind of combines the best of two worlds. It takes the media presentation as separate streams, right? The experience coordinator is now the player, and this is what's different with SGAI. SGAI is now that this is going to be supported internally to players instead of having to build that on top of or deal with it in the stream. And the seamless requirements is you can have a single player instance, and internally it might have multiple player views or other things that can go with that. And we're back to having a distributed system, so we can handle unlimited scale in theory with this. And we'll talk on what that really looks like and what it means and what we're actually be building to help with some of that. But this is what SGAI really is. It's a matter of taking the client side and bringing a lot of the best things that you could do with server side from the experience perspective, but having it taken care of internal to the players. And that's pretty powerful when it works right. So application, server, player, and who manages what for each one of these. So personalization, right? This is a real key thing. One of the benefits of streaming is that now, hey, every user who's watching something can get personalized ads in a perfect world when there's actually enough inventory to cover that, and it's actually something you're interested in. It's a separate problem that we're not going to be tackling by doing DAI. So the idea here is that it can be customized for each view. You're going to get the most return on actually making money when you're doing personalized ads. And that's be done through something called cost per thousand CPM. And it can be great experience when it works right? It can be things like GeoGroot for geo locale. You can have it where, so that therefore, like, hey, we have sets of people who are getting personalization. So everyone in this region of the world or the state or so forth might get that. Or it can go down even further. Or non-personalized, right? Everyone sees the same thing, and that is kind of the old status quo, which doesn't always work so good when you want to make more money, which is what advertising is all about. Easier to implement, and you can have some caching benefits if you do that, though, but you make less. So how's ads actually get signaled when we're talking of streaming? The most common one is going to be working with SGAI, SGAI 35. There's a wonderful large spec where there's great libraries for parsing it, all sorts of good stuff. But ultimately, it's a timed metadata tag, and it's fairly the standard for ads. It can be presented in different ways in the manifest. If we're talking about HLS, which is what we're going to focus a little bit on for now, at least for this talk, although the project, I hope that we're also going to be tackling some more stuff with Dash, is that within an EXDX date range tag, you can specify additional metadata, including the SGAI data, which will help with actually determining the ad call and the ad experience that's going to happen. Doesn't have to be a date range. There's other times you can use queue outs, queue ins. Different server-side solutions require different tags, to be honest, sometimes, or expect different tags, but they're going to do similar things. Here's an example of a date range tag, including a SGAI property. So you can see we have a SGAI 35 out, and you can see the encoded SGAI message here, which would then need to be decoded. But wait, what happens when an ad is signaled? We're going to take a quick little detour just to give you a feel for how ads can really add up into a lot of calls and work. So you have an ad signaled, it's then going to go to your ad decisioning. It's going to look to load a VAST file, for instance, if this is live. A VAST will specify multiple ads. So we have a pod with 3 ads. Each one of those could have a mezzanine or an MP4 file, potentially a multi-variant playlist, which is what we'd be looking for. Those multi-variant playlists will have the individual renditions, and then the renditions will have all those individual segments. And if you think about from a server-side ad perspective, you actually oftentimes have to load all of these playlists together up front for each ad and ad break, and then start worrying on your stitching for all those, because you never know what your client's going to be loading when. And that's part of that downside of that centralized system of so much work that has to take place to be able to stitch these ads for a large scale of users in a single location. On top of that, then there's still also tracking calls that will go out as well. I have a bunch of resources and such I've already pulled together. I'll be sharing. That's going to be in our GitHub for, hey, you can see VAST examples, the spec, all this other stuff. But ultimately, it looks like an XML file. And within there, you'll have multiple ads within the break. And there's also something called VMAP, which we're going to be learning about later on, not today, that also can handle for VOD and larger experiences that need to have multiple ad breaks in there and so forth. So back to what we were originally talking about, let's see what SSAI kind of looks like. So this is an example of SSAI, single variant that's been simplified. We had our kind of normal tags coming in here. You can see segment 1 was fine. We have a queue out. We're saying we're going to be doing this break for 15 seconds. And then now we have different segments that we're going to want to replace. And what the server actually does is says, oh, okay, between this queue out and this queue in, normally we'd have more ad data potentially that's going to be in there. It's now going to replace those. And you can see here now injected that with these other tags, which would be what is returned back from the SSAI service in a very, very simplified perspective. Looking at something a little bit more realistic, you can see here we have actually with a date range tag specifying a little bit more information, including if we wanted our creative signaling and other stuff within here. And then that can return into what we would want in the end. Let's not focus on SSAI. We want to focus on SGAI. What does SGAI actually look like when we're looking at this in an HLS perspective for now? So this is how we're going to be working with interstitials. Here we're going to be using a date range tag. And we're going to specify, in this case, the COM Apple HLS interstitial. This will allow it to work automatically within HLS.js and also the AV Foundation and so forth. Doesn't currently work within the Safari native player, I believe. We have our start date, our duration, so we're saying it's a 15-second ad break. What type of resume offset we want. Are we going to restrict things like skipping and jumping? And you can put in example other stuff just for any custom things as a beacon if we want to. But key thing here is pointing to what we're going to do. This is what we want to play. This is a simple one where it's just an X asset URI. It means it can point to one M3U8 and then it will inject that one. We're going to take that further and look at something called an asset list. So here, very similar, but now we have an X asset list versus X asset URI. An asset list is going to point to a JSON file in HLS. I added this as a little bonus thing. Ultimately, interstitials and SGAI is geared at the player. But what happens if the player doesn't support this? What would happen if you gave that to a Roku device right now? Well, it wouldn't do anything. But what if I want to still support things like SSAI? Well, you can by still triggering on that existing data as well. If we add in where a tag that has both the SGAI data, for instance, that's needed by your SSAI service, and also has things like your your asset list URI and so forth, you can have one tag that could support multiple types of ad solution. Just wanted to call that out. Here's an example of what the asset list looks like. And ultimately, in the most simplest form, it's JSON with a assets array, and each one of those objects will have a URI and a duration. And each one of those URIs is going to point to an M3U8. This would be fine for displaying that. It won't do much more than that, though. If we want to, we can take this further. SVTA has been working on a specification on how we can transport a lot more of the needed advertising data that you get within VAST into the asset list, and how we can structure that so everyone can kind of have some standards and do it the same. This is an early example of some of the proposals around that. And a lot of what we're trying to get here is things like all of our tracking data with ads. With ads, you always have things like quartile tracking, you know, when the ad starts, 25%, 50%, 75%, so forth. How do we actually have to translate that stuff to make sure that this works and looks good is actually going to be a big portion of what we're going to do on the initial part of our project. Because ultimately what we're going to be tackling is to try to take on generating these asset lists from our VAST calls, and a little bit more, of course. From a Dash perspective, this is what this looks like. We have a single event payload. Here, this is going to turn into, I think this one was for the SSAI side, and you can do it with your different periods, integrate those, that's fine. What we want to look at is the SGAI. First option with Dash is using an X-link. So here you can see we have an MPD, we set up periods, we have a period and a X-link pointer. That will then allow us point to a period. So that X-link will point to a separate XML file, which is just a period, not a full MPD. This is the older way of how you can kind of do this stuff within Dash. There's been a lot of work to get fuller interstitials working where you don't use a separate period. You actually point it to a fully referenced MPD. There were some problems with it at first, but I think they've worked out most of those. And an example of this is now where you get to use a media presentation insertion. So within your event stream, you can set up by event, you specify your presentation time, and you can point to your alternate MPD, in which case you can point it to a full MPD. That's great when you need to think about, hey, this ad has already been packaged, it's sitting on this ad server ready to be loaded. That's what we want, and then we can sequence those out. So what's this look like? In SSAI, you know, we have our content preparation, it goes to its origin. We have our signaling that indicates, we then start loading that content, and then it goes to a content conditioner, this ad distribution system here. That's going to be your SSAI provider that's going to make these ad decision calls, load in the content playlist, stitch the content, and then bring it back, right? So this is where, you know, a lot of work happens in this content conditioner element here to make this happen, and it is kind of that you know, central system. And then things are loaded, things are tracked. With SGAI, the simple approach is when you're just using an asset URI pointer. We're not going to really focus in on this. I'm leaving this here just for reference, but this could actually be integrated then at the packager that it determines that, but then you won't have personalization. But you could have all of that type of stuff being determined and still using your ad server, injected into your playlists, and then you're kind of good and it works. What really is powerful when we want to use the asset list and enable us still to have dynamic ad insertion, that's what this is going to be. So here, you know, similar flow, we have our kind of publishing, our content preparation, our origin. We start signaling when we have an ad in the manifest. Oh, I want you to drop an ad at this location. But what we're going to be doing is we're going to be pointing it to a proxy. So that asset list is going to go to a service. This is what we want to build. This ad proxy service will then make calls to the ad decisioning service. That's going to be where it's loading in the VAST data or VMAP and so forth. Parsing it, and that can be complicated, by the way, not so much as the parsing, but there's things called wrapped VAST and so forth, and go multiple layers that has some complexity. And then it's going to generate the ad playlist, or in this case, an asset list response. The ad playlist would be for Dash, the asset list for HLS. And then once that's received, it can load in the ad content, load the segments as necessary, and then do the tracking. And that's what's kind of missing today, right? In the industry, if you wanted to go do this, you have to build out some kind of middle service right now to generate those asset lists for the HLS side. There's nothing that can do that right out of the gate. on its own. There's some awesome stuff. Matthias on here made something called Super Streamer, sweet open source project that we're going to be looking at and potentially borrowing, sharing, working on some stuff on. That kind of takes an end-to-end approach and does some of the packaging as well as even the transcoding, especially in a VOD perspective, while still enabling you to inject your interstitials in your asset list and so forth. So it's pretty powerful. Really cool stuff there. Ivan also just posted up something a couple days ago for creating a live solution with their open source stuff and being able to integrate in with HLS interstitials and whatnot. Not seen a lot in the Dash world just yet, but that doesn't mean that it's not something that we can't help fix as well. So what this project is going to be focusing in on is working on building out that SGAI service endpoint and how we can make that very quick, very powerful, very scalable, and make it so it's easy. Now, if you want to start doing this, great. You can point it to where you want to load your vast dynamic calls, get that information back, get an asset list, and lo and behold, if you're using a player that supports SGAI, you now have ad integration. While also looking to drive forward with some standards on how we're going to do things like impression tracking and so forth, which is right now a bit of a gap. It hasn't really been tackled yet. So this is a really good opportunity for us to show how this can work, apply some new standards as they're coming out, and hopefully help the industry with further adoption on SGAI. Bunch of other resources in here. Most of these are also in the GitHub that we're doing. And I hope I didn't talk too fast that nobody understood anything I said.
Yay, thank you. A lot of claps for you. Woohoo. Questions, ideas?
Yes, one question. The JSON representation of a vast file, like, is there anything spec-wise from what Zachary made, like wrapper ads, or like is everything resolved on a server before the actual payload is being crafted and inserted in the interstitials assets JSON list?
I mean, I think that my interpretation, and this is something that I'm excited that we're going to hopefully get input from Zach, and if not involvement from him on this as well. But I believe like the theory and the spec that he's been working on is that you collapse all that wrapper stuff down. Either way, you have to take it down to what data you want.
Yeah.
And I don't know how that stuff layers. Like that's honestly an area I just don't have a ton of experience within VAST. I've seen them. I barely have ever had to work with the wrap multi-tier stuff. So I'm gonna work towards finding out and learning and sharing as I go, because I don't have all those answers yet.
Yeah, sounds nice to have everything resolved on the back end.
Yeah, sounds like maybe we can also, like in some moment of the project, whatever, do some proof of concept plugin or whatever in any player, in some player, to do some early implementation of the tracking stuff with mentioned.
Yeah, definitely. And this is also like where we can, with this in hand, this is going to be something that will be more hopefully valuable. That the goal kind of being is that the players, when they're supporting SGAI, will also start adopting support for the impression tracking directly from the asset list, so people don't have to build that in. So that's actually a big gap right now. Is that even if we follow the SVTA spec, players won't track it. You still have to track it yourself. Players should track it if they're supporting SGAI, and we make this as, we kind of get this ratified as the standard for how to handle impression data.
Yep.
Oh yeah, definitely. Yeah, might be worth checking. Speaking with the guys from Cast Labs as well. Like they released Presto ads a couple of weeks ago, and actually implemented it for a Belgian company. But the API is just like, it's very nice. It's very clear. It's structured. Couple of minimal, set of methods. Just makes a lot of sense. And basically, like, it all comes down to, I've started this ad, I finished it, this is my quartiles, that kind of stuff.
Perfect. Yeah.
Awesome. Any other question?
Yeah, just one thing, given the potential for ballooning scope within this timeline.
That would never happen.
One thing, Nico can speak to this as well, with the last year with CMAF HAM effort, we tried to break it down in terms of project management. So to avoid trying to boil the ocean, I would like strongly encourage starting with the simple case and not trying to solve like like not assume we'll get to that, because I think there will still be value add for core functionality as a V1. Cool, perfect.
Yeah. I mean, I think we're gonna definitely like step this up and see like, hey, this is our core thing we need to do, which is simple and direct, and actually shouldn't be a ton of effort, but there's a lot of things we can then go from there. But before we say we're going to do everything, let's actually do it and confirm like, oh shit, well, we didn't think about that. So we don't bite off more than we can chew. I'd rather go back for more bites.
Perfect. Yeah, and then with the Dash stuff, there were a lot of conversations on interstitials and the equivalent in Dash. It sounds like basically everyone is saying X-Link was a left turn instead of a right. So I would strongly encourage, it feels like they're going to try and formalize around what you were proposing with option 2.
Yeah.
With it.
I mean, honestly, I'd like to do both. The difference of what we're going to have to do, though, in my opinion, is if we go with an X-Link, and once again, this is one of those, hey, do we have the capacity to take on one more byte? What we would do is then proxy the Dash request through our service to trim down a full MPD to a period and inject in the tracking data, right? Which is probably what we're going to have to do potentially, which is one of the things we have to kind of figure out, like in Dash, in asset list, we already kind of know a good way to do that. For integrating all the impression data. For Dash, I don't know if there's a good set system, and even in the stuff that Zach's been working, I don't know if it's really clear on how we want to deal with that there. I think it is, but what that means though is we're going to have to do a proxying of those Dash manifests and then inject those on the fly, which is fine. Like that's the difference of, instead of creating an asset list, we're just modifying the manifest, but we still have to load it, parse it of sorts, and then inject into more tags. And that's, no one's doing that. Like I'm starting to see like cool stuff's coming around for people who are getting more interested about SGAI and building out some of this. But I haven't seen anything much yet. Maybe I haven't looked too hard, I guess, either, I'll be honest, on the Dash side. But that's also kind of the common thing, is things start on one and then branch to others. Thanks, Christian.
Excellent. Great. If there is other questions, Slack, because if not, we are going to run out of time. Thank you, David. And let's go with mics and let's learn about media over quick and players.
Cool. Thank you. Yeah. All right. Can you see the slides?
Yes.
Good. Okay. All right. So let's get started. So a bit about me. I'll skip this. I've worked various places, including Mux and a CDN, and now I'm at Ideas, and we make Norsk, which is kind of a media server type thing. Jumping right into background on media real quick. If we're going to build a mock player, you might want to know what mock is and why mock exists, why we're building this new protocol. So I stole this from Ali Bagan. It's basically kind of the existing landscape of protocols in terms of latency. It's a little bit of a simplification. Essentially, the HLS- HTTP adaptive streaming traditionally is kind of 10 seconds on up. There have been efforts to get below that threshold and closer to 1 second, which is ambitious. Other things like HESP also kind of play in that space in the middle. And then there's WebRTC, which we're using right now for this call. WebRTC works great for conferencing, small groups of participants, and it can be made to work at broadcast scale, but you're really going against the grain for various reasons. So WebRTC tends to be constrained a little bit by the main implementation, libWebRTC, to those kind of to being tuned for those conferencing applications, and so the latency ends up being kind of pinned, and you can't necessarily play in this middle area as much as you might like. So if you want to kind of do broadcast scale streaming to large audiences, but at low latencies, there's a range in here that is hard to reach with the existing protocols. And this is where Media Over Quick is initially targeting, offering a solution. We're designing it in a way to be somewhat generic, so that you can kind of cater to use cases in this gap. But one of the reasons that these use cases are not well served today is because you don't have a lot of control over latency. You're kind of pinned to one side or the other of that divide. So one of the things that we want to offer in this new protocol is the ability to make that more of a tunable thing. So you can kind of decision on how do you want to deal with congestion. It's going to happen. Do you want to drop things? Do you want to skip ahead? Do you want to when do you want to trade off quality, skipping? All these things are things that you could have more flexibility with, but existing protocols don't offer that type of flexibility. So as a result, in theory, we could eventually serve all of these use cases with Media Over Quick. And so there's no reason that we couldn't do higher latencies. And already some of the members of the working group are intending to use Media Over Quick for conferencing type use cases as well. So it will definitely be going down to lower latencies than just that gap. And it also could go up to higher latencies, and even you could serve bot assets using Media Over Quick. So let's go back a little bit and kind of revisit the protocol stack. So we're on the internet. We're talking about delivering video on the internet, which uses Internet Protocol, v4 or v6. Yeah, Luke is mentioning in the chat distribution and contribution. I'm talking mostly about distribution here, but that's the other area where we're intending to be very flexible, is dealing with both, going out to the large audience and also, taking ingest into services. So you can have, internet packets routed over various mediums, optical links, electrical, whatever, carrier pigeons. But it all comes together at one layer of IP. And then on top of that, you can use UDP, which is pretty much IP with not much else on top. So UDP diagrams basically give you nothing else on top of IP, very little. They're very nearly raw IP packets. So you don't get any reliability for your delivery. So you can put things in datagrams and you can send them out on the internet and route them somewhere, and maybe they'll arrive. If you're lucky, they will. Which is great. You don't have to wait for anything, right? It's low latency. Fantastic. Wonderful. But maybe you actually want to make sure they get there. So eventually we developed TCP, and TCP is connection oriented rather than being messages that are delivered individually. And it offers reliable in-order delivery. So usually if you're sending messages across the internet, you kind of want them to get there in order, or you'd like to be able to figure out if they're in order, the things that you've received. TCP offers that at the protocol layer, and to provide that in-order delivery and reliability, it has to do things like retransmissions, which involves a trade-off, right? You have to wait a little bit. If you have to retransmit things, you have to wait longer. And the other trade-off, if you want ordered delivery, is you have to accept some head-of-line blocking. Head-of-line blocking means basically you can't send more things like further in order if the first thing isn't sent first. So because things need to be in order, head-of-line blocking is the natural consequence of that. TCP also involves congestion control, because we should be good citizens of the internet and not consume all the bandwidth. It's better for everyone if we kind of play fair. So Christian actually has a really excellent blog post that I love to reference for this part. You should just go read his blog post on kind of the history of how we ended up at HTTP adaptive streaming. But eventually we built on the TCP side using HTTP things like HLS and Dash. So you're taking advantage of the fact that that low-level protocol is giving you reliability, ordered delivery, those sorts of capabilities, and you don't have to worry about that. And also there's things like CDN networks, ATM machines, CDN content delivery networks, and that means that you can get better economies of scale for delivery. You can kind of fan out. Thank you for putting the link in. Yeah, go read that post if you want the whole history on this side of things. It's definitely worth a refresher. So yeah, so if you take advantage of TCP, you can do some really great things, and we all have seen those. But you have to deal with this head of line blocking issue. So TCP is connection oriented, and the consequence of ordered delivery is head of line blocking, which means you're sending some information, and you send 1, 2 chunks of information, third chunk of information gets lost somewhere, gets dropped. Maybe there was congestion and the the buffer on the router was full, and so that one fell off the end. It never arrives, it doesn't get ACKed. You realize that it's missing, from back and forth from one end to the other, and you have to send it again. You'd like to send 4 though. You have 4 ready, right? But you can't do anything with 4 until you send 3 again. So this is the head of line blocking problem. And with TCP, the entire connection is delivered in order, and you don't have, short of opening a separate connection, you can't get around this head of line blocking issue. So there are latency consequences for that. And if you would like to build something like a video conferencing application, you're probably going to want to do something different. So then you go back to the UDP side. UDP is great for low latency. However, it doesn't give you any of the other stuff that you might want. So reliable delivery is on you. That now is at the application layer. So we've developed, things like RTP, and we've developed things around RTP like WebRTC. So now you can have in the browser stack, a way of doing all of this. But there's a lot that lives up in this upper layer now. There's a lot of responsibility on these parts to make sure that things get there in time, to do decision making on that. And the way that WebRTC ended up being developed, that all kind of got glommed together into one thing. It's a whole stack of protocols. There's a lot more than RTP inside this box. But implementation wise, you ended up with basically libWebRTC. And yeah, so this is kind of the 2 sides of that gulf of live streaming. You've got HLS and Dash, which have like great economies of scale. You get the reliable properties of TCP, and you've got kind of the UDP side with WebRTC. There are other protocols too that are UDP based, but again, you have to deal with a lot of stuff up in that higher level protocol when you're doing anything on top of UDP. So to recap, you've got UDP on one side, TCP on the other. There's some things that you want for both. Like you want some of this reliability, but you don't really want to deal with connection-wide head of line blocking because you'd like better latency characteristics. You'd like to be able to send 4, even though 3 has gone missing, because at the application layer that 4 doesn't depend on 3 maybe. And it would be nice if you didn't have to wait for 3. So why not both? And that's where Quick comes in. So Quick basically gives you some of the properties that you want from TCP and some of the properties that you want from UDP. And the key way that it does it is through stream multiplexing. That's kind of the key feature that we are most interested in. There's a lot of other features that we're also taking advantage of, but the stream multiplexing is kind of the key bit for achieving low latency properties. So we jump ahead, we look back at our TCP head of line blocking problem. Quick works a little bit differently. you can have multiple streams that are going at the same time. And so if something gets lost and needs to be retransmitted, the only things that get blocked by that are the other things on that particular stream. So you can now make decisions about, okay, I know that I don't need this frame of video maybe for the next one, because the next one happens to be a keyframe. So I'd like to just send that keyframe because it doesn't depend on any of the stuff before. Or alternatively, you know that things are ordered and you have a p-frame that is useless to you until that keyframe gets there. So put it on the same stream and you can, get some of that reliability, get that ordered delivery, and you can start to now tune things for the latencies that you want to see and make the trade-offs that you want to make. So Quick is fantastic, but we need a way to map media onto that. And that's where Media Over Quick comes in, saying, okay, we've got video, we can package it up various ways. How can we build some standards around doing this delivery so we can get some of the advantages of HTTP adaptive streaming at latencies that are closer to other real-time protocols. And part of that is building out things like CDN capacity. And so HLS and Dash are cheap to deliver because there's CDN networks that have a whole bunch of servers that know how to do HTTP, and HTTP is just a generic thing. It's just objects that are going, from one place to another. They can be cached, they can be fanned out. We would like to have the same property exist for lower latency protocols, and that's where Media Over Quick Transport comes in. So, recapping, we're filling this gap with Media Over Quick. Media Over Quick Transport is the protocol that will allow us to build that CDN capacity. Here's some of the graphs and where things started. Luke was the author of a graph called Warp. He's in the chat here. That ended up getting merged together with some other drafts in a kind of the same space. And a working group was formed to come up with a generic protocol. So we can come back to that later. So Quick also has another related protocol called Web Transports, and Web Transport is what allows you to use Quick in the browser. So this allows your JavaScript applications to access an API that gives you access to that stream multiplexing and Quick, and you can open a connection and take advantage of these properties in the browser. So now, similar to WebRTC, you have access to something in the browser that gets you lower latency delivery capabilities. Media Over Quick Transport sits on top of Quick and/or Web Transport. And this is, again, the piece that gives us the ability to build these fan-out networks. Yeah, okay. So here's where this sits in the stack. So Quick sits on top of UDP. It provides some of the capabilities that TCP does. It also rolls in TLS, right into the transport protocol itself. So you can save some round trips on handshaking, and you have encryption baked in, a bunch of nice properties. Web Transport sits on top of that. It's, like I said, it's similar to WebSockets in that it's initiated with an HTTP thing, but as soon as it gets started, it's its own thing, and it mostly gives you access to raw quick semantics. Media Over Quick Transport, the spec currently can run over either raw quick or over Web Transport. And then on top of that layer, we have streaming formats, and this is where we have manifests and define what packaging to use, and it could be all kinds of things. The idea is that the fan-out network is generic, and we can deliver all kinds of different things over that. So there's a draft we've been working on that retains the Warp name that Luke originally had. It's changed shape back and forth several times now. It initially was CMAF based. Now it's looking like we'll probably support a new web codec based packaging format as kind of the default, and CMAF as an optional thing after that. I could see Dash doing its own streaming format that's CMAF based, later for IPR reasons mostly. But yeah, so the streaming format layer is where we actually like tie the media bits, the packaging, the manifest together with the mock transport protocol. This is that. The protocol itself has some control messages and an object data model. Everything is delivered as objects, and the objects are members of groups and potentially members of subgroups as a way of controlling what streams they end up on. And then those groups are strung together into tracks. And so you subscribe to a track and then stuff just gets pushed to you. And just recently, we also added a new verb called fetch, and that allows you to deal with things that are in the past. So when you need to like go back and fetch stuff, you can fetch stuff. There are some open source implementations. We also have a media server called Norsk. This has a mock output now that's now available. There's a Docker container you can download, get a trial license, play with it. And there are a few media over quick player implementations. The two big ones are mock.js, which Luke originally wrote, and I'm now maintaining support for the working group drafts in a fork of that, and mock encoder player, which Jordi Sanzano from Meta wrote. It was originally based on mock.js. And we have like some things that we want in each of them. And both of them were just kind of developed as like tech demos. And it would be nice to either build on those or build something new with a fresh perspective that really takes advantage of what Media Real Quick can do. So you can follow the GitHub. There's a place to talk about things, the meetings weekly. And here's some more resources. We'll be having that workshop next week where I'll go into more detail on the protocol itself. Thanks.
Woohoo. Excellent. Great. Questions? We have a lot to learn.
Yeah, so in terms of the project, we'll probably be spending some of our cycles at first just scoping things and doing a bunch more like deep dives into the details of how to implement this stuff. So if you're interested, like this is just a teaser of what else there is.
Yeah, totally. Last year, maybe Christian remember, we create like a huge whiteboard. We draw IO to put all the concepts together and try to tie them up. I think this will be like the perfect case for newcomers, like me, to learn. I have all the concepts over there and see how stuff works together. So I will start doing that for the first meeting for sure. Great. Questions? So maybe we can use like something to understand also from I didn't know that the Norsk you already have something implemented over there that could be used for also like a server to try on with the player. That's something on the table for us.
Yeah, the benefit of Norsk is we have a whole bunch of protocol inputs and outputs, so we can like translate between anything to anything. And now we have a mock output, so we can take RTMP in or SRT in or whatever you want in, WebRTC in, and then turn that into a mock output to test the player with. Right now, that is using kind of the early CMAF based streaming format. We'll probably move that to one of the web codecs formats once there's more direction on that. But yeah, things are kind of in flux right now. I'll probably continue to support CMAP as well, because that's particularly useful if you want to reuse those objects for traditional HTTP delivery.
And is there already any implementation with the new, the lock container?
Yes, and that's Jordi Sanzano's mock encoder player JavaScript implementation. So that uses it was lock, and then it was determined that there are some gaps in the early lock spec. So Jordy spec'd something else that's very similar called Web Codec Packaging, I think, WCP. And then Mo also updated the lock spec. So now we've got temporarily two very similar packaging formats, and I think those are going to be merged back together again in the next couple weeks.
And I also forked lock as well.
yeah. And then Luke has a whole nother thing called
So,
transfork that isn't even mock transport at all anymore. But
It's basically there's a JSON playlist. It's actually very similar to ham. In fact, we could even use ham. And then the actual frames is just the timestamp and the bit stream. So everybody does their own thing because standards are hard.
So something we can like I'm thinking just aloud. Something like me that is learning with this, I think a very good stuff to get into is to know the difference between the implementations, because as you mentioned, we have Luke's fork, Luke's previous fork, and Jordy's. That's right.
So in terms of players, there's at least mock.js that Luke is maintaining is now transfork. So that is not now wire incompatible with the underlying transport protocol, but useful for reference because he's doing a lot of innovation on the player side and the catalog format side. So even though we can't interop with that, it's useful to look at. And then I'm maintaining a fork of mock.js that is maintaining compatibility with the working group drafts. We're up to draft 05 now. Draft 07 just came out, working towards compatibility with that. I'm trying to basically keep pace with all the spec changes that are happening there. I also am maintaining a fork of mock.rs that is following the spec changes more quickly. Yeah, and then
so we never had interop with the media layer. That was always kind of on the back burner. There is, if you want to interop on the transport side, it's just the drafts update so often, and there's like the major breaking changes that, I mean, we can send messages to each other. That's what the type of interop is for the most part. So I wouldn't worry too much about which flavor of mock. I think what Mike was saying, it's more about like they all have the same concepts. It's just the actual wire encoding is different. So it doesn't actually matter what you interop with, just pick one.
Yeah, the working group just this week was talking more seriously about doing interop at the media layer now. And so there's a draft that Jordy and Alan put out that documents what mock encoder player is doing, which is kind of that LOC-like packaging format. And it has just like really fixed track names and things like that. It's like you send these exact tracks and this is an interop target.
Perfect for proof of concept.
Yep.
So also, like, I imagine that people from the OTT world will like, oh, I want to still use CMAF because I have compatibility with HLS, Dash, and maybe mock. And people more from web conferences world, and hey, I want people who want to achieve the lowest latency possible. Maybe the lock is your answer. Is that correct?
Basically, yeah, and it's particularly the conferencing use cases are particularly sensitive to the packaging overhead, especially on the audio side. And so that's the main driver for lock. And then compatibility with existing stacks is the main driver for wanting to use CMAF. But CMAF is complicated because there's a whole separate set of specs that you need to look at that are not IETF specs, and so it's hard to work with that within the IETF, which is why I think we might end up standardizing a streaming format for CMAF based stuff, actually like on the Dash side, like doing the mock transport layer in IETF and having some kind of streaming format, probably lock based in the IETF, and then like come back around and standardize CMAF stuff in Dash.
Yeah, just for a quick context, if you do the CMAF fragment size as one frame, which you need for minimum latency, that's 100 bytes of just headers. And that's almost the size of Opus. So if you're using CMAF for like conferencing, you've just doubled your audio output size, bit rate.
Got it.
That's
Yeah.
the main reason for lock, is it's just like it's unacceptable for minimum latency.
Makes sense.
I have an import layer. You can give me CMAP and I'll spit out lock basically. And that's, I think, the way forward.
Oh, you already have that? Is on the repo?
Again, it's the fork, so we'll have to what the
Awesome. Great. I know maybe just one question. If someone has another question, if not, you can find Mike, me, or whoever in video dev. And I think, yeah, we are going to see each other again on 1 week. Start with the project and discuss and learn together some of this new cool stuff and try to, do some contributions to the community. And that's the main goal of everything. If there is no other question, thank you everyone for being here. And yep, let's continue conversation on Slack and see you in a week.